Hello, good evening, everyone. This is Startup Grand Riyadh, and this is our meetup with Prof. Sajung, founder and CEO of Predictiv. Startup Grind is an international community headquartered in San Francisco. We have multiple communities in all parts of the world. Our mission is to build the right ecosystem for each startup to grow in a healthy way. We have 3 values: help others, give first, make friends. Our sponsors are Amazon Web Services and the Ministry of Communication and Information Technology. Those are our previous guests. Last is Mohammed Al-Zarbi, and starting with Mona with Walid Al-Angari. This is our amazing team, and it's growing. And if you want to start a chapter, if you want to volunteer with any chapter in any city in Saudi, please contact us through our Twitter account. And
Okay, السلام عليكم ورحمة الله وبركاته everyone. معاكم أخوكم عبد العزيز الميسر، واليوم يعني متحمسين ومتشوقين جدا لحوارنا مع البروفيسور سوجونغ يان، السي او of Predictiv، شركة Predictiv المختصة في فهم الدي ان اي. وان شاء الله في هذه الجلسة الحوارية نبغى نعرف معلومات أكثر عن Predictiv، وأيضاً عن المشاكل والمشكلات اللي موجودة في العالم اللي يحاول البروفيسور ساجونغ بحلها هو فريقه. إذا تسمحوا لي بحول الآن من اللغة العربية إلى الإنجليزية. First of all, we would like to welcome Professor Sajung Young. We are very happy to have him today with us. Professor Sajung is the CEO of Predictiv. During the last decade, he actually more than a decade, he is an expert in multiple elements of genetics. He was an adjunct professor at bioinformatics at the Johns Hopkins University or Johns Hopkins Hospital. Today we're going to discuss first of all his experiences from early on until recently. We would touch upon his experience also at the Johns Hopkins, and then we'll move forward with the startups section of the professor, and finally we would talk more about Predictiv and the problems that Predictiv is trying to solve, and how can we, as a society or as a community, participate in such thing, and why is it important? So first of all, Mr. Sajung, Professor, ahlan wa sahlan. Very happy to have you here with us today, and welcome to, I believe you are in the region now, so welcome to the region.
Yeah, thank you very much for the great introduction, and it's a great honor to be here. I greatly appreciate for your kind and welcome invitation. Yeah, I'm currently in Abu Dhabi. We work area, the Hub 71. I'm there, so I like to talk about my brief background. That so I got the PhD in biomedical sciences and started teaching at Hopkins for many years. And over the time, I realized that people, instead of writing a paper and hoping somebody used my research result, I want to do it by myself with my colleagues. That's the entrepreneurship is about. Instead of your paper getting cited by other authors, but I rather make the team and solve the problem together. That's why I got to the entrepreneurship world, and that's why I started my business journey in San Francisco. And yeah, so I'd be happy to talk about it over the time this time. Yeah, thanks.
That's actually very exciting. San Francisco has a very dear place in my heart, as I used to live there for a while. So anyone who lives in San Francisco automatically is dear to my heart. Okay, so Professor, for starters, if you could talk a little bit about the area that you work in, DNA, genetics, that category of life. Probably the viewers or the listeners, not necessarily all of them are aware of, the details of it. Why is it important, and the businesses in it? So could you shed some light on that area, DNA, genetics, and everything in between?
Yes, I like to talk. Yeah, sure. Why DNA? Sure. So after getting PhD, actually, I went to MD program medical school after getting that. So when I see my patient, and they always ask me, "Hey, doc, I was not. I was a PhD doctor, not the MD doctor then, but they are asking, hey, doc, what do you think about what I have? Can you tell me what disease I have, etc. Can you tell me what would be the best medication?" And at the back of my mind, I was always thinking that if people get sick, there are only two possibilities, I think. One, people got the sickness from environment, such as you got the bacteria or virus or something like environmental reason, or you have on your body's genetic reason. So in my opinion, I was thinking that, okay, I only know your environmental information. Basically, I don't have 50% of other information, and how am I gonna make it right? I mean, also as a professor, when I tried to give the exam, and then, like multiple choice exam, if the student cross out 50% out of the 4 choices, 2, and now they have a 2 right potential answers, we call that guessing. When you pick 1 or 2. But that's what we are asking to physicians. We don't provide our own genetic information, but try to ask them to guess it right. So I thought it's really unfair to me, I mean, as a more like a medical professional, to guess. And then, the consequences are great because, if you prescribe wrong medication, think about all the side effects, or not effective medication, just wasted time and energy, and suffering more, etc. So all those suffering the patient has to experience by themselves with their own body. So I felt it's really unfair. So, okay, since my brother, I have a twin brother, and my twin brother is also faculty at Johns Hopkins. Also, he's a faculty at NIH, National Institute of Health in Bethesda, Maryland, USA. He's been teaching genomics for more than 10 years, 10 years to more than 1,000 postdocs there for next generation sequencing. So we thought, okay, why don't we provide a tool to, in real time, give them relevant genetic information as well as the health information. That way, at least we make them physicians to know all the full picture to make the right diagnosis. That's the beginning why we we worked on DNA.
That's actually very exciting. And, for the first time when you were mentioning, when you have 4 answers and you eliminate 2 answers, still you have to guess. This makes me think about all the times that, I went to a doctor and the doctor ended up guessing something, and how life would have been if doctors aren't guessing anymore. They could make more informative decisions in regards to medications or any type of support. Okay, so
but here, let me just add one more thing. So here, we not only provide all the information, but we went one more step forward. That is simulation. So why don't we make digital copy of ourselves? It's called digital twin, right? Digital twin. And has all the DNA information and all the health information, and then simulate it. So before giving the medication, we give the digital medication to my digital copy, and then simulate, see what happens, and then with a good thing, then take it. So that's the Predictiv is about. Predictiv is building DNA-based digital twin to simulate for the drugs and etc. Not only providing the, yes, we do provide the relevant genetic information, but also before taking any action, medical action, we simulate. Yeah.
That is actually the closest thing to mind-blowing to me, that we could actually do that. And in a few minutes, I would like to talk more about Predictiv. Now, I just want the first part, I want people to get to know you. So in the last years, you have worked, other than in the health and science area, you also worked as a chief executive officer in a couple or a few companies. So were you trying to solve the same problems back then? So back in 2013, you were at Dr. Mix, and then we have Zoomed. Were they also all aligned in the same direction, which is DNA related things, or was it different?
Yeah, I only have a one life mission, that is saving lives. That's why I went to medical school. That's why I got the PhD in biomedical sciences, all these things. So I want to save most of the lives. And I think from the family friend perspective. So let's say some people, let's say one person, friend or family member dies like 20 years earlier than normal life. Normally people live up to 80 years old. And then let's say this person, whatever the reason, dies at 50 or 60, then we lost about 30 years of that person's life. But normally it's known that each person has at least have a relationship with 10 to 15 different people. So socially, we are losing 15 times 30 years of the life. So which is 450 years of the social life, which is so huge loss. And so we want to prevent that. We want to reduce those life loss. And, I want my loved ones, families, friends, kind of forever, I mean, as long as possible. Then we were thinking, what would be the best way to lengthen the healthy lifespan? And we thought it's preventing the preventable death. That would be the lowest hanging fruit, I thought. So that's why Predictiv became Predictiv. The reason was Predictiv. In order to prevent something, we wanted to be proactive, take a proactive measures, proactive medicine. But nowadays, due to the insurance cost structure, etc., you have to build some code, and then we have to kind of wait. We need to wait until that person, we could have a writable, usable, billable code. Then, so we practice reactive medicine. But in order to lengthen the healthy lifespan, we do need to work on the proactive medicine. And then I thought this, if you play soccer or football, if you know where the ball is coming, it's very easy to prevent, as a goalkeeper. But if you don't know where it's coming, you have to wait until you see it. And a lot like a penalty kick, etc. Often you kind of get late on that. So at the later stage of the disease, even with the up-to-date medical technology, there are a lot of things we cannot do, a lot of diseases. So why don't we practice a proactive medicine? That's then I thought, okay, predicting it right is the maybe key to do that. So that's why it's a Predictiv. Before then, Dr. Mix was about the doctors need to think about the omics, for example, proteomics and all these omics. Genomics is also omics too. So we wanted to be, the physicians be more knowledgeable to each patient. So that's why we started the Doctomics. And then after that, we started Zoomed. Then I thought telemedicine is also important key back in, 5-6 years ago. And then in order to solve the accessibility issue, we thought, like I went to the grocery store, and when I buy buy the salad, often by weight. Heavier more the stuff I buy, I kind of pay more. So I think that's really fair. And then, why don't we do that for the same thing, so physicians always complain that, oh, I'm not getting paid as as much as I think I worth it. And then, so why don't physicians decide the rate, and then why don't patients decide how many minutes they're gonna do the consultation? So then, so we could make it very accessible and affordable. So that was second startup. So basically, out of my entrepreneurial journey, my goal was to lengthen the healthy lifespan. Thank you. Yeah.
Honestly, that's very, such a noble and beautiful mission. And genuinely, I hope that you succeed multiple times in doing that. Because really, it's a need. It's not a luxury. It's not anything of that sort. It's something that I think will revolutionize our lives in healthcare and beyond. So now let's talk about Predictiv. For starters, if we could, put it, I know that you spoke a little bit about the digital twin, which is a very appealing concept, but could you talk more about Predictiv? What do you guys do? And what are the main problems that in this version that you're trying to solve? Let's start with.
So let me start why we got started with the Predictiv. About 7 years ago, my father got diagnosed with a rare cancer. The incidence of this cancer was 10 in 1 million people. So just by guessing it, you'll never be able to guess by chance. Since my twin brother and I analyzed thousands of people's DNA, but not our parents, we decided to analyze our parents' DNA, then found out his cancer was actually predictable and preventable. By the way, he's okay, but he has to go through the stomach resection surgery so he had to took it out 1/3 of his stomach. Which is kind of, not good, but still.
But
so
at least it was prevented and predicted one way or another. That's fascinating. I'm glad that he's fine. I'm glad that he's fine. I wish him health.
Yeah, right. So if we if we have done it earlier, he didn't need to go through surgery, etc. But obviously it was kind of late, but it's okay. Then my twin brother and I was thinking that why don't we open this opportunity to other people? But before then, we thought another thing. So he suffered from this rare cancer, but he might have another serious conditions in the future. So why don't we prevent that? So we try to analyze important diseases, or how about Alzheimer's, how about stroke risk, how about diabetes, etc. So we went, although it took about 1 year for us to analyze up to 250 diseases. And then one day, my twin brother came to my place and basically actually showed this kind of a window. And then, think about this window, and there is a screen door to keep the bugs out. And then let's say screen door is there are about 20,000 diseases, 50,000 diseases, something like that. So if we have a screen door set up whole window, yes, we could prevent bugs coming in. But what we did out of 250 diseases were just blocking the 10% of the window with the screen door. So his point was, we're still gonna have the bugs come in. Well, in order to do the use as a preventive tool, we have to do all. Then we do need a completely opposite way of doing this thing. Instead of starting with 1 disease, 2 diseases like that, and all the way to 100,000 diseases. By the way, that's why all other competitors, like for example 23andMe and Invitae, etc., they are stopping at 100 or 200 nebula disease, but we decided to do a completely opposite approach. That is something like Yahoo and Google. Let me just talk about the Yahoo and Google. About 20, 30 years ago, there was Yahoo was dominating internet search engine. And then, so you had to register your website, okay, and then sequence, we will index everything, and then we'll provide a relevant result in the short time. So what we did was we compared to the reference genome and then report the whole thing and then compare to the 20,000 diseases, etc. So that it was a completely opposite approach, more like a Google approach. So that's the predictive technology. Yeah.
That's actually very fascinating.
Yeah.
So you're trying to, okay, would we, you know, at least how does it look in the future when we talk about predictive or that industry as a whole? How does it look in the future? Would it be the kind that is, you know, an open source where all specialists could dive into that search engine and understand these things? Would it be, how are we going to utilize such science in currently and in the future? And also, I'd like to add one thing. So, and allow my comparison. I know it's not even close, but
yeah,
when you look at websites or programs such as Ancestry, for example, they're trying to utilize the DNA in a very basic way of just understanding the, you know, who shares the same DNA. Can we see more services and products coming up on top of what Predictiv is going to create in the near future? So if you could talk about the future of how you see this industry, that would be great.
Yes. Let me start with that. 5 years from now, I believe there will be two type of patients. One patient with their DNA-based digital twins built versus another type of patient who didn't build their DNA-based digital twin. So the one who built their digital twins, they will ask, okay, I have these signs and symptoms. What do you think I have? And then, so basically combining the DNA-based digital twin with the AI doctor, and then basically asking that or simulate before taking any drugs. But those people who didn't build a digital twin, that they can, they have to just, doctor is going to say, oh, I want to give this medicine, and this medicine happen to be known have this serious side effects. If you experience that, please let me know. I will change it for you. But you know, in the meantime, this person might suffer maybe permanent or non-permanent damages. So that's the future I see. And then, so basically what I'm saying is pretty much everybody would need a digital twin to simulate and ask, because human body is very complex. And one of the hardship as a medical professional was that finding the right information. So have you ever experienced that if you got hospitalized, I'm not sure in Saudi, but in US, if you get hospitalized, people ask the same questions over and over. For example, you know, you ask the same question to the nurse, and then doctor asks that. And then when you go to the imaging person, ask the same question. Yeah.
Horrible, especially when you're tired and exhausted, but they keep asking the same questions. Yes.
Yeah.
Global pandemic.
Yeah, actually, one of my patients mentioned that, you know, hey, you guys don't even know what I told you. So I mean, you know, I told you a couple of times, you don't even know what I told you, and how you're gonna make the right diagnosis that I don't even know, the patient don't even know. I mean, so that was one of the complaints I heard when I was in the ward, hospital. So the reason it's so hard, I mean, physicians and healthcare professionals asking the same question is that the medical record is somewhere when they write something, and then it's somewhere in the file. It's very hard to pull it up. And then so that's why people and then, you know, and it's enormous amount of the information. So I think the solution for that is that to build a digital twin, and then whenever people listen, I mean, or physicians need that information, just ask the digital twin instead of asking the person. And of course, we have to ask the same person and all these things. But the point I'm making is that in the future, digital twin will be very useful for the medical practice, because in this case, my example was just information. Okay, what was my temperature? You know, did I sweat, etc. I mean, that's okay, but you can ask a couple of times. But you know, what if those things you are not checking those crucial information, drug side effect or drug-to-drug interaction, etc. That's avoidable, totally avoidable error. But I think that's why DNA-based digital twin will be very useful in the future. And then in the future also, it could be used for the various purposes, because digital twin could be, let me give you the example of the baby newborn screening. Newborn screening, especially for the GCC region, there is a culture that sometimes cousins marry each other, and then genetically similar cousins marry each other. I mean, it's a cultural tradition. I think that's a very precious cultural tradition. I think instead of discouraging that, we need to do the medical intervention that for the newborns, we have a genetic test, such as, what about the Gaucher syndrome? What about the what about the some other Edwards syndrome, etc. All these syndromes, we check maybe 50 to 100 common items. But what I'm suggesting is that you need to analyze people that baby's own genetic background. Also, father's DNA and mother's DNA, and then you combine it. You can also know what kind of mutations the baby would have or baby already has. So that way we can provide a customized newborn screening plan. So, I mean, that's just one example. There are tons of examples, but what I'm saying is this digital twin will be very useful for many use cases.
Wonderful and true. And whether it was here in the region or globally, I think there is always that risk when it comes to any type of social interaction, whether it was marriage or the reproduction or anything of that sort. Usually there are issues, and instead of being discouraged or you have to understand it. You have to understand it from a scientific point of view. So I absolutely do see how that could be very useful, whether it was for babies or for even adults in understanding diseases or how to prevent such. Okay, so really from talking, I'm really excited to know where is Predictiv now? Are you, whether we talk about it from a startup point of view or from a company point of view, are we still at prototyping or minimal viable product? Are we post-launch? Like, where is Predictiv now when it comes to scalability, for example? When can we see Predictiv all over?
Yeah, we are post-market, and so this technology has been developed over the last 5 years. And then last year we had paying customers, just more like a pilot, 160 customers we tested in the market, and we got the various feedback from customers, physicians, and the medical community. And then so as a company-wise, we raised pre-seed funding of $1.15 million from the US. And then so we got the I'm not sure you know that Tim Draper is a famous venture capitalist in the United States. And we got the funding from them, and Draper Associates, and Plug and Play Ventures is also very famous venture capital there. So we got the funding from them, and we got the Republic. And then that's our pre-seed round. And then this year we are just about to close around probably next month or so. We already raised 2.5 million, and then about 1.5 million soft circle. So we are finalizing that deal. So so funding wise, we kind of secure that funding for the next 2 years, and we like to focus on the more like national level project. So what we are like to do is instead of focusing on one-on-one, I mean customer sales, we like to do a bigger scale. So let me actually show you
So
what.
Instead of B2C, you want to go more towards B2B or B2G type of.
Yeah, correct. Oh, by the way, can I share the screen, by the way?
Absolutely, please.
Yeah, thank you. I think screen sharing is not allowed, I guess.
We'll give that to Dave. Dave, if you could help us in projecting.
Oh yeah, got it.
Professor, yeah, perfect.
So this is the Saudi Arabia, the health statistics. And when you think about it, what causes the most death? As you see here, 2009 to 2019, over the last 10 years. So this is Saudi statistics, and then it's about which diseases cause the most death. And as you see here, over the last 10 years, it's pretty similar. So what we are proposing to the, thanks to Plug and Play and the CHI, Council of Health Insurance, the regulators, we got the pilot opportunity. And what we like to do is that in 2029, we do not want to see these diseases anymore here. So we want to knock out all these things. How do we do that? We like to do it through the intervention that incorporating the precision medicine. For example, for ischemic heart disease, for those people who don't have the disease yet, for the normal people, we want to identify the high risk group so that by genetically, because there are some propensity for the high risk for the ischemic heart disease. And then those people will be closely monitored by themselves. They know, okay, I have a high risk for this, so I have to watch out all these signs and symptoms, and then learn by patient education, what is the early symptoms? Is it more like a heavy, very heavy heart feeling, something like that, or weight or something like that. So people learn what is to recognize the early signs and symptoms for those people who are in the high risk. And then we are discussing to do the pilot that for the acute condition, when people collapse, you only have a couple of minutes to hours. So in that case, I mean, if you have a complete blockage, you only have a complete couple of minutes. But if you have a partial blockage, yes, you have a couple of hours. So in that case, for coronary artery heart attack, then we want to put the best resources, Saudi's public health resources, for example, ischemic heart attack response center, to the right place, considering the current infrastructure and road conditions, and then future of the ischemic heart disease, heart attack population 5 to 10 years from now, etc. That way, when you superimpose all these things and with the predictive analytics come out of the best acute response center placed in the right places, we can save the most lives. And then for the chronic conditions, once people have the ischemic heart disease attack, and then there is a let's say that person survived, but there is also high chance that that person would have another heart attack. So need to be closely monitored. So those applying the right chronic condition management, etc. So so in summary, for these conditions, if we use the precision medicine to identify the risk group before getting the condition, and then during the acute attack, putting the right resources, during the chronic management, doing the right, better chronic management, we believe that, we could make these guys out of this list, and we can save many lives. So that's what we like to focus in the kingdom.
That's lovely. So basically, how you're focused on solving the genetical, the chronic issues. So governments and entities are focused on the the injuries and how to solve them rather than the health related elements. I absolutely love that. So now I would like to talk a little bit about markets in general. So, each country, when we go to, you would see a specific trend in the country, whether it was a problem they're trying to solve or anything of that sort. So, for example, if you go to Egypt, you would find more people working in financial technologies. If you went to Saudi, you're going to see more people working on logistics. So each country has that trend. So now when we're talking about DNA-related startups, how is the scene that you witness in the United States? What are the challenges that are there? What are the opportunities that are there? If you could talk a little bit about the scene of that in the States. And afterwards, we'd like to talk about the same scene here in the GCC. How understanding are investors when it comes to such projects? How understanding are governments for such thing? In general, tell us your entrepreneurial experience in that regard.
Yes, that's a great point. So let me talk about the Silicon Valley first, because I'm kind of familiar with that. So in Silicon Valley, the 23andMe and Invite and all those commercial companies, or Ancestry.com, they focus on more like, they even put the commercial at the Super Bowl. So it's really popularizing that, and people are very well aware. And then also COVID, which is the RNA. So people got familiarized those viruses, all these things, and the genetics. So in the Silicon Valley, it's more like they focus more on the leisurely, I'll say, more, instead of as a medical grade solution, more like each individual just pay whatever the small amount of money and then check to see how much relevance I have, etc. So that was the trend in the Silicon Valley. And then, and as you've seen in the Veritas Genomics, there were some companies try to do the medical grade solution for the whole genome sequencing, but they had to retract, so they had to change their business model, etc. So in Silicon Valley, so far for the genomics field, it's not was not that working well. So that's the my impression I had. And then in the academia, so for example, NIH, National Institute of Health, so they started a big, huge sequencing project to provide that kind of benefits to many people. So that's another big trend, government or academia trend. So launching the big sequencing project, and and some other countries like UK Genomics England, they sequence 500,000 people and try to reach 1 million. And then also US 1 million, and then people, and UAE, they want to sequence entire citizen. I mean, Emiratis. It's called Emirati Genome Project, which is really valuable because, and I don't think any country so far ever tried to sequence entire citizen yet. And then, so in GCC region, so like UAE and I mean, they are starting to have the strong interest and doing this in the national level. And in Saudi, NEOM is a good example. NEOM, they try to build a digital twin, and then they want to build a futuristic city with all this precision medicine enabled. So the NEOM's goal is to bring the 10 million people into the region, and then they want to sequence entire citizen, I mean, if they want, and build give the digital twin to them, etc. So Saudi is very advanced and world leading country. And not just NEOM, and I talked to the King Faisal Hospital, and they are really up to the, they made a genomics department about 20, 30 years ago. And then they are really cutting edge, leading the world in this field. Yeah.
That's wonderful. So I'm glad that you actually do see the differences between each country and a country. Not that it's good or bad, but it's just different that to see B2C, B2B, B2G in different countries and how they're playing based on their goals and objectives. Okay, so when it comes to challenges for such startup, you are in the DNA industry. I don't know if that's the industry name or whatnot, honestly, but you're in that area and you're trying to innovate and create a startup, a business, profitable startup in such a thing. What are the challenges that you try to solve on a daily basis from a startup point of view? What are the I bet they're completely different than a person who's working in logistics or anything of that sort. So what are the challenges that you face on a daily basis in such startup?
I think one of the big challenge is that people didn't think about it before. Okay, why should I need a digital twin? I'm perfectly happy. I mean, I exercise and eat right. I mean, eat good things, and I mean, I basically don't need a digital twin. So since it didn't exist before, for the innovation which didn't exist before, I mean, they are perfectly fine. People are perfectly fine without it. And why should I have to have that? So that's the biggest challenge. And my answer to that is that I usually talk about the example. For example, vitamins. People take the vitamin pills, and then people take vitamin pills while they feel like, for example, oh, I need to improve the memory, so why don't I take the omega-3 or omega-6 or vitamin E for the eyesight, etc. So just people read from the internet or the books and or media, and then they buy those vitamin pills and take those kind of things. And then they are perfectly happy about it. But what we are saying is that, you have an inborn propensity. So if you search your digital twin, you know what kind of vitamins your gene has a mutation to make certain vitamins, so lack of it. So you need to, so what we could do is that we can tell you by analyzing that thing, you need certain specific vitamins, more amount. And as you know, especially fat soluble vitamins, if you take more than what you need, it's actually harmful. So more the better is not always working here. So I mean, water soluble, it's okay normally, but fat soluble kind of you need to watch out. So what I'm saying is, by building the digital twin for the nutrition, we analyze and then we let you know what your body needs, not what you think you want. So that's the kind of argument we are making to the people. And some people take it, and some people think that still, I'm happy with whatever genetic vitamin. I'm happy with it. I mean, that's their decision. Yeah.
I understand. So basically, if we want to put it into two problems, the number one is awareness. People are not aware, so you have to convince them or teach them or explain to them why is it important to do that. And the other part is most people are reactive rather than proactive. So as you mentioned, if they're feeling something, they will take vitamins, pills, whatever it is to react to that rather than understanding their genetics and moving forward with a proactive plan. So that's pretty much the two challenges that you're facing on a daily basis.
Yeah, and then let me actually show you what it means. So for example, for this Jane Doe, if you just type the vitamin, this person has a genetic mutation for the vitamin K and vitamin B12 and vitamin D. So due to the specific reason, I tell you, so that GGCX gene mutation at the chromosome 2, which position, etc. Here is all the evidences. So we tell them, so this person needs some vitamin K related information. I mean, vitamin K fortified strengthened vitamin K, vitamin, etc. So so here is, we also provide all the references by linking the NCBI. So we tell them, oh, here is the GGCX, calcium regulation, vitamin K, etc. So here is all the evidences. So we practice the evidence-based medicine, and also we tell them what we need. And also, let me just tell you one more thing. Let's say one person is feeling dizzy. Oh, I feel dizzy. Maybe I might have anemia. And then how do I know? I mean, of course, you can do the red blood cell count, the test, all these things. But another also important piece of is that genetics. And then, for example, this person has a lot of anemia, different types of anemia propensity risk. So this kind of information is helpful to go through the differential diagnosis procedure and pinpoint what's the culprit for this person's dizziness. So that way we can practice evidence-based and precision medicine more better, I think. Yeah.
That is fascinating, and I absolutely love the dashboard. It's fairly user experience friendly to be able to evaluate and read reports. And truly, the search even looks similar to any search engine that a person is used to. Absolutely wonderful. Okay, so Professor, now surprisingly, we have a few minutes before the end of this session. So I would like to ask you a very simple question, yet not so simple, which is, going back few years back, what are the learnings that you would give to yourself? What are the learnings that you think any entrepreneur, whether it was in your industry, what are the problems that you would like to shed light on? What are the opportunities? What are the learnings that you learned? Any elements that you think any entrepreneur who is watching this session, who is in the same industry as you, should know and who would benefit from? So the mic is all yours.
Yeah, thank you for this great question. Actually, I prepared one slide for this, so please allow me to talk about it. Maybe it will take probably 4 or 5 minutes, but so this is the learning that I want to make. So here I'm starting the entrepreneurial journey. For the problems of where to find a business model, go-to-market strategy is very difficult to find. And then for the solutions, where to put our product design focus, who are our customers, and then what features should we have for the market, who are my competitors, and for the team, how to recognize and write co-founders, and then how to solve our company's own problems. So I want to talk about this. So for the problems, so the first thing I want to talk about is that where to find a business model and go-to-market strategy. Finding the business model and go-to-market strategy is very challenging, and I think that's the way I found our business model and go-to-market strategy. If I think of the earning money, which is entrepreneurship, of course, business involves, business 101 says, definition of business is the profitability and sustainability. Yes. If you think that perspective, it's very hard to find the go-to-market strategy or business model. But if you think of helping people, what type of people should we help? That kind of clears and then opens up the eyes. So in my case, my mother suffered diabetes for the last 20 years. And we were doing the joint venture. And then, for instance, I was a researcher at NIDDK, which is the Diabetes and Kidney Institute at NIH. So my mother knew I was one of the experts in this field. So, oh, today I got the blood sugar level so high, 200, 220, etc. So whenever I hear that, I was always kind of worried that for the complications. So in that case, for this joint venture, we found out with our business model came very easily that why don't we focus not only on the blood sugar management for the diabetes, but also on the complications management. So with a single drop of blood test, we rotate the test for the kidney, so some markers from all these things so that we prevent the limb amputation, etc. As you know, one of the most frequent reason for the limb amputation is still diabetes, which meaning that blood sugar monitoring is not 100% effective. So, so we do need to check all these things. So, going back to this, if you have a hard time, at least for me, I found the business model and go-to-market strategy whenever I focus on helping people. And then, secondly, for the solution, where to find, and then where should we focus on our solution? So I like to give you the airplane design. So if you were to build the airplane, there are passengers and there are pilots and stewardess and stewards. Who are most important? Of course, passengers who pay for the airfare is most important, of course. But think of all the stakeholders. Giving the some good space or good design for the stewardess to help them to rest whenever they need to do, etc. That's gonna improve the service, etc. So, so what I'd like to say is that for the customer, and then customers and stakeholders, when you consider that, solutions might clear out, and then also for the market, who are our competitors. What I'm suggesting is, anybody, your customer, could think when considering to use your solution is a competitor. So there are so many, like thousands of competitors possible. So what I'm suggesting was, which I do all the time, is I allocate certain time of the week and I study them. So I recommend that too. And the team, how to recognize right co-founders. Yes, capability is very important, but those people trust and passion together is also very important too. So that's what I want to point out. And how to solve company's own problem. I want to, as people work together, there are some conflicts. So what I like, when there is a conflict, I like to bring out first, why don't we look and examine it carefully first? So let me give you the example. For our company, PR team, our CEO, previous CEO wanted to have the right to publish those like LinkedIn posts, all these things easily without any big hurdle getting signed off. But our chief medical officer wanted to sign off because there are some medical content she felt it's responsible. So those two people conflict, those two department conflict. And then what I said was, as a CEO, I made a dividing line. Okay, if you use certain resources like FDA or something like very trustworthy resources, you can just do it without chief medical officer information. I mean approval. But if you use something else, you need to seek for the approval, something like that. So when each department or people conflict each other, look and examine it carefully first kind of helped. Entrepreneurial spirit, how to prepare to be an entrepreneur. I think having expertise definitely helped for me. So, the fact that I'm teaching at Hopkins in genomics is a very competitive place, and the fact that I'm teaching many years there is the kind of indirect proof that I at least have a good enough skill set. So having that kind of expertise definitely helped. And then secondly, learn other relevant fields, for example, finance, PR, marketing, sales, etc. As a entrepreneur, instead of delegating 100%, at least high levels, I felt it's helpful to have some high level knowledge. So that's why I went to the MBA program. So I did a double major in the entrepreneurship and healthcare management from Johns Hopkins, and then I was a finance major for 1.5 years, etc. So I tried to learn as much as I can, and then lastly, just do it. And as a conclusion, what's the startup entrepreneur spirit? I like to talk that restart up hourly or minutely. So this is the point that this is my conclusion, that startup, the exciting thing is starting up. And you start up your startup business probably every couple of years. I don't know, 3 as a serial entrepreneur, you do maybe and 3-4 year cycle, etc. But what if you start your startup problems every hour or every minute? I think that's the startup spirit. Thank you.
Absolutely wonderful. First of all, I would like to thank you for the short entrepreneurial session that you just gave. I absolutely love it. And to be specific, I love the fact that you should not limit yourself to only one area of learning or one knowledge area. You should be able to understand multiple things that are related to what the problems that you're trying to solve. And of course, the restarting up your startup is a concept. I think adapted within startups and initiatives that we're leading. Professor Sajung, honestly, it was such a pleasure and a lovely conversation today with you. Thank you very much for your valuable time. We enjoyed it and we learned a lot. I would like to thank also Dave and the whole Startup Grind team for facilitating this beautiful conversation. And of course, I would like to thank all the viewers, listeners, whether it was through Zoom or YouTube, Twitter, anything of that sort. Thank you, everyone, and truly appreciate it. I think now we're on time, and have a wonderful night. Thank you very much.
Thank you very much. Yeah.
Thank you. Bye-bye.
Thank you. Bye.